Learn to program. 30 minutes to be able to write a program. I'm Scott Kramer. I can be reached at education@visualsuccess.com, and this is my first intro to learning to program. So let's talk about what this course is going to do for you. It's going to assume you've never programmed before. It's going to teach you about the concepts and approaches of programming. And it's going to teach you how to pseudocode and teach you why pseudocode is important. So what is a program? Well, pretty much the definition is a program is a plan or system under which action may be taken towards a goal. Probably straight out of the dictionary, I wouldn't mind saying. Programming is a sequence of coded instructions that can be inserted into a mechanism, such as a computer. Yeah, way back in the day, they used to have mechanical computers, so technically a mechanism is accurate as well. So what is pseudocode, and why do we care about it? Well, pseudocode says, if I could spell dictionary correctly, pseudocode is a program code unrelated to the hardware of a particular computer and requires the conversion of that code by a computer before the program, for the computer, if you will, before the program can be used. So in other words, you write this kind of pseudocode, it's not really able to be run on a computer, it actually needs to be converted before you put it on a computer. So why use pseudocode? Well, it's an excellent way to learn how to program, because it provides you the wonderful ability to understand how a computer thinks. It gets you to think about programs as little tiny steps in your head and how you make those steps to conform to the logic and action and conditions that you're going to define. So pseudocode eventually can help you implement the pseudocode into an actual program, kind of a precursor step, getting you thinking in the right way and then converting it. So pseudocode has no real grammar rules. It's entirely up to you to define your own rules. However, these rules must provide for granular steps with clear grammar, logic, and action and conditions. Grammar and logic and actions and conditions of any computer language, even pseudocode, are called syntax. Any language whatsoever is called syntax. Like if you were speaking French, there's a way you put the verbs in and so on and so forth. There's a syntax to the language. Okay, you're probably confused now. You want to go back, do little baby steps. Let's do that. Let's slow it down a little bit, roll it back, try to make it easier. So let's talk about pseudocode, okay, and syntax requirements. The pseudocode has to have granular steps. The smallest possible manner of defining something would be considered granular. So saying, hey, bake a cake as a step is not granular. It involves too many sub-steps. So in order to be granular, we would need to know each exact step of baking the cake. Ingredients, measuring, temperatures, process, blah, 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 blah. All that stuff would go into it. So that would make it granular. Just saying generic like bake a cake or build a car is not granular. So in our syntax, we have to have clear syntax. We have to know what our rules are. So you cannot change the syntax rules of pseudocode in a program once you define them. It would be like saying, I'm going to define my little program as say hello to Bob, and then I'm going to execute say hello to Sally. Oh, by the way, I changed the meaning of say hello to actually mean slap across the face. So if I did say hello to Bob, we'd say hello to Bob, and then I changed the meaning, and now say hello to Sally means slap her across the face, something she would not expect, I'm sure. Okay, so let's apply that a little bit more directly. You cannot say, if oven temperature exceeds 350, then adjust to 350, so my syntax here being if and then later on say, oh no, I'm not going to use that anymore. I'm going to use this new one that I just came up with called when the oven is 350 degrees, go ahead. So when and go ahead being my, basically my logic there. You have to stick to the same syntax. So it would always have to be an if-then if you started with if-then. Or if you want to go with when, go ahead, you can do that too, but you need to stick to that syntax throughout your whole program. Obviously, if you change to a new program, you can define different syntax. Perfectly possible, perfectly reasonable. So any given language syntax will need to include conditions, like, well, we'll go into that in a minute. Logic, do this under these circumstances, and actions. What are you actually going to do? Let's talk a little bit more. So conditions might be like, hey, you've fallen down, or fall down, or whatever you want to call it. That's a condition. You're falling or falling down. It exists. Another condition might be right leg in front of the left leg. Logic might mean conditional logic. So logic is a somewhat, sorry to use the word condition, but it is effectively if then. So if condition exists If something is true or false, whatever it may be, then do something else. So how do we apply that? Well, if you've fallen down, then stand up. Fallen down being the condition, stand up being the do something or action. You can use this for many, many different program scenarios, and it's very, very helpful, the if-then. So let's go on to action syntax. Action might be something like stand up. So let's go on some more. Let's talk about our pseudocode. We're going to create our own little pseudocode here for the purposes of this demo example course, and we're going to use that to actually fill in some code. So rules and grammar of any computer language, okay, even pseudocode are called syntax. We already know that. Let's continue with our baby walk into our own pseudocode language. The following rules are going to apply for our individual program this time. You can change them, but this is for this particular demo and course, we're going to do this. Our conditions are going to be limited to left foot in front of the right foot in front of the left foot. Those are the only two conditions we have. Okay? Everything else doesn't matter. Our actions are going to be limited to only move, whatever foot, right or left, foot forward. So you'd have move right foot forward, move left foot forward. Those are two actions. You don't have both at the same time. There's no move right left foot forward. You only have one foot to move forward. And our logic in our little example is going to be if condition exists, then perform action. So you can see, we can, just doing basic ahead, schooling ahead here, the conditions would be if left foot in front of right foot, then blah, 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 move whatever foot forward. Okay, so you can see where we're going with this. So let's talk about our simple pseudocode program. So programming is defining the steps required to achieve a goal. Let's take an example of that. And let's do a baby's first two-step walk, since you wanted baby steps. Moving one foot in front of the other in style of a program, or pseudocode program in this case. Let's leave out everything else, like balance, vision, conditions, whether I, poop in his pants or whatever. Let's just go with one foot in front of the other. So if we're doing that with just two simple steps for right now, it could be, the program could look like begin program. Tell baby to move right foot forward, right? So that's pretty straightforward. Tell baby move right foot forward. Then we say, tell baby move left foot forward. Okay? Do we know which foot's in front of the other foot? Not yet. We're just making it really simple for you. Just very simple. Tell baby to move a foot forward. Tell baby to move the other foot forward. Very simple. End program. 4 lines, done. Okay? We had reproduced our first baby step. Yeah, we probably need to expand on it, and we will, but we've started with our most simple pseudocode program, and that's it. Beginning the program, telling the baby to do one foot forward in front of the other, tell the baby to move the other foot in front of the other. Ending the program. So let's go on to expanding that. Here's what we're going to do. We're going to say, adding a condition now. So now we're going to say, hey, we're not only going to move the foot forward, but we want to see which foot's forward first so we don't fall over. We can't move the right foot forward and never move the left foot. As you know, when you walk, you'll fall over. So let's add a little bit more complexity to the program. Again, let's leave out everything else. Balance, vision, obstacles, poop in the pants, etc. Let's see how it would look. So we'd start with beginning the program. If, here's our conditional logic. Our logic is the if and the then. If and the then. So if the left foot is forward, that's a condition, then tell baby to move the right foot forward. So in other words, if we were a program, thinking programmatically, if the computer comes along and says that the baby's right foot is forward, then that condition would not be true, and we would not tell the baby to move the right foot forward. That's what logic is for. You have a condition, left foot forward. You have an action, tell baby to move right foot forward. And then it's only acted upon if it matches and meets the logic conditions. In this case, if the condition, left foot forward, is true. Let's continue on with if the right foot is forward, then tell baby to move the left foot forward. So we can clearly see, if we're reading this, just plain old English, if the baby's left foot is forward, then go ahead and move the right foot forward. If the right foot is now forward, okay, then go ahead and move the left foot. So you got your 2 steps. Well, you're probably saying to yourself, well, what happens if the baby's left foot is not forward? Maybe the baby starts with right foot forward. So let's follow that through. We begin the program. If the baby's right foot is forward, well, that first line number 2 would not be true. Left foot forward is not true, so it would not tell the baby to move the right foot. The next line says, is the right foot forward? Yes, if the right foot is forward, in this case it is, then we would tell the baby move the left foot. True, we technically didn't get the 2 steps, but don't worry, we're just learning the program. It's no big deal. We'll get there eventually. So obviously we end the program. So let's convert this code to actual real code that a computer can run. I know, we're going fast, aren't we? Don't worry, we'll get there. So in order to do that, you have to know the syntax differences. So remember, we have our syntax for pseudocode, and we have a syntax for a given language. In this case, we're going to actually work with Java. Just simpler and easier. So what are the differences between our pseudocode and Java? So let's say what Java has. Java has, surprisingly, an if condition, then action syntax, just like our pseudocode. It's a little bit different. It's described as if, and you have to have the parentheses, condition, close parentheses, open curly brackets, they call it braces, and then action, close braces. So Java uses an if-then thing, but it doesn't actually use the word then, okay? And it also doesn't use the convenience of having just if condition, then whatever. It has to have the condition surrounded by parentheses, and it has to have the action surrounded by braces, curly braces. That's the only difference. So all we have to do is convert ours to that. So if we take ours and convert the ifs to Java ifs, we would look like this, beginning the program. If, open parenthesis, left foot forward, close parenthesis, open curly bracket, tell baby to move right foot forward, close curly braces. So we can see it doesn't use the word then, but we do know, and Java knows, that anything inside the curly braces represents the then, the action, and anything inside the parentheses represents the condition. So it's going to evaluate the condition, true or false. Is the left foot forward, yes or no? And if it is true, in other words, the left foot is forward, it will execute the element inside the curly braces. Let's continue on. It should look very similar probably for the next one, right? It does. The only difference is we change the condition, change the action. And now we've ended our program. Again, very simple. We've converted our pseudocode over to Java. Are we done? We ready to run it? We're ready to code in Java? No, we got more syntax changes to make. Don't worry. But we got to start with one step at a time. Baby steps, if you will. So let's go on to the next element of that. That's going to be, let's talk about more Java stuff versus our pseudocode. So Java, like many languages, is case sensitive. So in other words, the words system, 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 spelled with different case typefaces, are all different to Java. They mean literally different things to Java. So it's important in a case-sensitive language to use the correct case at all times. What does that mean? Right? We'll go on and explain in a minute. Don't worry. Java has the equivalent of a tell, like we tell baby to move foot forward, that prints out information to the screen. And Java, it's called system out print. Okay? What are the syntax of system out print? System out print has an open paren, a double quote, whatever you want to print out, in this case, tell baby to do blah, another double quote, followed by a paren and a semicolon. Okay? A lot of stuff just to do. Unfortunately, in pseudocode, we could, because it's our language, we define it as a tell, but unfortunately, to convert it to this language, Java, we have all these additional characters that have to be put in order to be able to do the same thing. Let's explore how that would look. Also, Java does not use a begin program or an end program. However, it does have something very similar. It's got a class and a main. What does that mean? We're going to find out in just a moment. The syntax is as follows. You're going to have, in Java, always for your little program, instead of begin program, you're going to have public class, my class. Then you're going to have public main, exactly in the syntax you've seen here. Don't worry, you can stop this and write it down. It's not a big deal. But this is generic, basic programming. These two lines equivalently in your mind mean begin program. Worry about nothing else. Don't worry about anything else. Just remember this means these two things are required in Java to begin the program. You'll notice the curly braces beginning at each one of these. Those curly braces have to be closed with a corresponding closing curly brace to tell it it's an end program. And we'll get to that. Let's continue on with our program and our changes required to meet the Java language. So, there's actually an error here. Java does not allow capital letters for all of its variables. In this case, the if is capitalized. I only did that so that you could understand that that's a part of the syntax. In reality, Java does not want a capital if. It wouldn't understand what capital if meant. It only understands lowercase. It'd be like saying to you, hello means hello to you, but if I capitalized it, it meant goodbye. That's what Java thinks. Java thinks the capital if means something completely different. It doesn't get it. It would be upset about it and goes, this is not syntactically correct. So just so you know that, I just did it for your purposes, for you to be able to see it clearly. In this case, if, condition, left foot forward, and then we have a system out print line, which is the same thing as telling the screen, tell baby to move right foot forward. Fairly simple. Again, we've converted our logic. Again, I'm using the capital if. I don't want you to be confused because Java requires a certain case-sensitive syntax. As an example, the word system there must be capital S and lowercase everything else. If you put a lowercase s or all capitals, it would not work. That is Java's syntax. And yes, I agree with you. Syntax of a given language can be a real pain in the you-know-what. However, that's the way programming works. It's the way the computer is able to decipher what we're doing. Some languages are more forgiving, some are less. Java's, in this case, is a little less. So we can see that we've had to do a little bit of work here on these lines. On the right-hand side, far right of line 3, you can see the end of the curly braces. You can also see that we also had to put inside the curly braces the system out print. And that also had its own parentheses and a semicolon. So you're having a lot of characters at the end there that are syntactically required by Java. Just so you know that that's what it's doing, and that is correct. So let's continue on. There's our closing curly braces, line 5, which tells Java that it's getting close to ending the program. We've ended the main. Line 2 is closed out by line 5. And finally, line 6 closes out line 1. So that's the equivalent of the end program. So again, we're fairly close to our pseudocode, but we've had some significant changes. We don't have the lovely little word then, which for me is kind of convenient, so I have to say it in my head when I'm looking at the code. In addition, you can see the error I've made on the screen with the if being capitalized for purposes of reading it, but in reality, if we were putting it in Java right now, we'd have to use lowercase. In addition to that, we have the system out print, which is required to produce something on the screen. But otherwise, this is a working Java program with the exception of those two if statements that need to be lowercase. But this is a working Java program right now. So let's explore some more syntax of Java. All programs need to know what a condition is, and they always evaluate that condition to true or false. As an example, is left foot forward maybe doesn't work in any programming language. It's either yes or no, or in this case, true or false. Is the left foot forward true, or is it false? There's no a little bit pregnant in programming. It's either yay or nay. Programs also use variables to represent true and false conditions. Variables can be used as a true or false condition. As an example, I could say the variable x, like in our math classes, and gosh knows we all hate that, is equal to 10. The statement, the logical statement, x equals 10, would be, it's actually a conditional statement, x equals 10 is true or false. Does x equal 10? Yes, it does. So it's true. If I said, does x equal 11? That answer would be false. That would be a condition. Most languages and good programming practices require you to define a variable before you actually use it. Java has true-false logic as well as variables. So we must define what left foot forward and right foot forward means for now to make it easier. So let's just say left foot forward is true. We're going to define it as true. And right foot forward is false to start the program off. Okay? So in this case, we're going to go back and adjust our program and just review it. Okay? So again, we have our starting the program off. We already did that. And I'm going to add in, okay, there we go. Sorry about that. There's actually, line 2 is, I misnumbered the lines, I apologize. But the Boolean left foot forward is true. So in Java, we tell it, hey, the variable left foot forward is a true-false, a Boolean is what it's called in most computer languages, is going to be equal to true. Okay? Then we can say, when we read this out, and again, I capitalize it so you could see the if, but it should be lowercase. If the left foot is forward. So in other words, it's going to evaluate left foot forward, the variable left foot forward, and it knows from above that that is true. So it will then execute the system out, print, tell baby to move forward, foot forward. Okay? Now, then we go to line 4, improperly numbered perhaps, again with the if, that should be lowercase. The right foot forward condition is true or false. Well, wait, I didn't define right foot forward up above, right? Didn't I say that all good programming practice requires you to define the variables? Well, in this case, right foot forward is not defined, so that would cause a problem. We'd have to add in a definition of right foot forward before or after the left foot forward so we could use it. We haven't done that yet, but just so you know. And again, we have our end program. So let's talk about programming in our little mini course we did here. A program is a plan or a system in which action is taken to achieve a goal. I think we can agree that seems pretty straightforward. Pseudocode is unrelated to the actual hardware and must be converted to code to be used by a computer. Pseudocode allows you to think in terms of small steps made up of conditions, actions, and logic. All languages have a syntax. You must follow the rules of the syntax. Converting pseudocode to real code involves replacing the pseudocode syntax with the actual language that we're going to convert it to's syntax. Hope you enjoyed the course, and best of luck to you.